Now see the question number 1. Electromagnetic waves are transverse in nature is evident by the first option your interference, second option your reflection, third option diffraction, and the fourth option polarization. See, normally we are having two type of wave. One we can say transverse wave and another is your longitudinal wave. In transverse wave, the vectors are perpendicular to the direction of propagation of wave, and in the longitudinal waves along the direction of propagation of the wave. So polarization can be done only for transverse wave. So transverse wave can be differentiated from longitudinal wave by the method of polarization. So polarization is the one of the method by which we can differentiate transverse and longitudinal waves. So our correct option here, option number 4. Question number 2. The difference between a microwave and a visible light wave is. The first option, only the microwave involves changing electric and magnetic field. Second option, visible light waves travel much faster through air. Third option, the frequency of visible light wave is much higher than that of the microwave. And the fourth option, microwave require medium to travel through space. As we know, either you can have light wave or visible light or microwave, both are electromagnetic wave, and these waves can be generated by the superposition of electric field and magnetic field vectors. How we are differentiating these waves? These waves are differentiated on the basis of their energy, and energy comes by the frequency of the source. So the microwave can be differentiated from light wave on the basis of their energy, and energy differentiation comes by the frequency. So we can say the microwave can be differentiated by the frequency. So our third option is the correct option. Question number 3. The magnetic field component in a plane electromagnetic wave propagating along positive x-axis is along the y-axis and is given by by 2 into 10 power minus 7 sine 500x plus 1.5 into 10 power 11 t Tesla. The electric field component of the electromagnetic wave are given by Ex, Ey, Ez are the xyz component of electric field respectively. The first option here, Ez is equal to 60 sine 500x minus 1.5 into 10 power 11 t volt per meter, while Ex and Ez is 0. Second option, Ez is equal to 60 sine 500x plus 1.5 into 10 to the power 11 t volt by meter. Ey is equal to 0 and Ex is also equal to 0. And the third option, Ex is equal to 60 sine 500z plus 1.5 into 10 power 11 t volt per meter. Ey and Ez is equal to 0. The fourth option is Ez is equal to 60 sine 500z minus 1.5 into 10 to the power 11 t volt per meter. Ey is equal to Ez is equal to 0. So first of all, wave is traveling along positive x direction. See, for electromagnetic wave, all the three vectors are mutually mutually perpendicular, and those are related by the expression like this. Those are related as this, related as E is equal to your minus V cross B. So first of all, as it is given, velocity is along x direction, that your Ci cap cross, and magnetic field is given along y direction. So that can be said as a B j cap. So this will be your I cross j or k cap. So electric field vector must be along k cap means z direction. So Ex will be 0, Ey will be 0. So modulus of electric field is equal to C modulus of amplitude of B. So that is your C 3 10 to the power 8, and amplitude of B is given as 2 into 10 to the power minus 7. 2 into 10 to the power minus 7. So this becomes your 60 is the amplitude. So this is nothing, it is the peak value. So now E is equal to Ez actually. Ez is equal to your E naught, and now sine, as the same term we are using here, kx plus omega t. The k value here given 500, 500x plus omega value given 1.5 into 10 to the power 11. 1.5 10 to the power 11 t volt per meter. So this is the Ez, where E naught is your 60. So our option number 2 is the correct option, which gives Ex 0, Ey 0, and Ez is your 60 sine 500x plus 1.5 into 10 to the power 11 t. So correct option, your option number 2. Question number 4. Question is given as, this question has statement 1 and statement 2 of the 4 choices. Given after the statement, choose the one that best describes the 2 statements. Statement 1 is, electromagnetic waves of low frequency are superimposed on a high frequency carrier signal by a process called as a modulation. And statement 2 is given as, low frequency electromagnetic message signal cannot be transmitted through long distance. So in these 2 statements, both the statements are correct, statement 1 as well as statement 2. The reason is that statement 1 means direct low frequency base signal cannot be transmitted, because for that purpose we require a very huge size of antenna. So that is not possible. So that's why we have to superimpose low frequency message signal into high frequency carrier signal. That's why the statement 1 is correct. Second is, the low frequency electromagnetic message signal cannot be transmitted through long distance. That's also correct, because these are having less energy or less power, so it is not possible to send for a long distance to maintaining the same energy. So their efficiency or their strength of the signal decreases if it is transmitted for a long distance. So both the statements are correct. So our option number 2 is the correct option. Hence answer 2 is the correct answer. The question number 5 is given as, consider an electromagnetic wave that propagates in the z direction with an electric field strength 1 volt per meter pointing in the y direction. Then the direction and magnitude of the magnetic field pulse that travel along with the electric field is? The first option 3.33 into 10 power minus 9 Tesla in negative y direction. Second option 3.33 into 10 power minus 9 Tesla in the negative x direction. Third option 3.33 into 10 power minus 9 Tesla in positive x direction. And the fourth option 9.99 into 10 power minus 7 Tesla in negative x direction. See, as earlier we have defined, the relation between electric field and magnetic field is written as like this. So when we are talking about the magnitude, there is no issue regarding magnitude. So magnitude of this your electric field by velocity. Electric field given 1, velocity of electromagnetic wave 3 10 power 8. This become your 3.33 10 power minus 9 Tesla. This is the magnitude. Now if we are talking about direction, direction we can get by the cross product. It is given electric field you are pointing in the positive x direction. So E is your positive x means j cap. And it is given the electromagnetic wave that propagate along plus z. Plus z means k cap. So we want j cap, and that j cap in k, and that will come your k cross. If we are writing k cross I, the k cross I give you plus j. So here it should be your minus I cap. So k cross minus I cap will give you j cap. So this is the direction of vector B. So answer is your magnetic field is your 3.33 10 power minus 9 Tesla propagating along negative x direction. So our correct option, your option number 2 is the correct option. Now see the question number 6. The electrons are accelerated in a television tube through potential difference of about 10 kilovolt. The highest frequency of the electromagnetic wave emitted when these electrons strike the screen of the tube is? The first option 2.4 into 10 power 18 Hz. Second option 3.6 to 10 power 18 Hz. Third option 2.2 10 power 17 Hz. And the fourth option 3.2 into 10 power 16 Hz. See, so energy of electron can be given as h into nu, and which is equal to your E into V. E is the charge of electron, V is the applied potential, where nu is the frequency. The frequency is written as EV by H. H is Planck constant. E 1.6 10 power minus 19. Potential applied is given 10 kilovolt. So 10 power 3 into 10 by Planck constant 6.6 into 10 power minus 34. Now we are simplifying this. 1.6 by 6.6 into, this is your 34 plus 4 38, this is 19 10 power 19, and this is your around, when we will solve it will come around 2.4 into 10 power 18 Hertz. So this is the frequency of radiation, electromagnetic radiation. So our correct option, your option number 1. Hence answer 1 is the correct answer. Question number 7. The magnetic field B and electric field E in an electromagnetic waves are? The first option in the same direction but with phase difference of 90 degree. Second option in the same direction but with a zero phase difference. Third, mutually perpendicular but with zero phase difference. And the fourth, mutually perpendicular but with 90 degree phase difference. See, electromagnetic waves can be produced by the superposition of electric and magnetic field vector mutually perpendicularly with initial phase here 0. So our correct option here, the electromagnetic waves are produced by mutually perpendicular but 0 initial phase. So correct option here, option number 3. So answer your third option. Question number 8. A plane electromagnetic wave of frequency 25 MHz travel in a free space along the x direction. At a particular point in space, the time electric field is given as 6.3 J cap volt per meter. What is the B at this point? It is given the electric field, electromagnetic waves are traveling along positive x direction. See, as per our relation between electric field and magnetic field vector can be written like this. So first of all, magnetic field vector magnitude E by C. E is the electric field which is given 6.3 and C is 3 into 10 power 8. This will be your 2.1 into 10 power minus 8 Tesla. So magnetic field value your 2.1 10 power minus 8 Tesla. Now about direction. If we are looking here electric field that is along J cap, so it is your J cap, and the wave is traveling along positive x direction, so that we can say minus I cap cross. Now when we are talking about the B is the magnetic field and we want here J, so I cross K when we are writing. So I cross K give you minus J, so minus minus become plus J. So B should be your K cap. So I cross K your minus J, minus minus become plus J. So direction of magnetic field your K cap and magnetic field magnitude your 2.1 10 power minus 8. So B vector written as 2.1 into 10 power minus 8 Tesla K cap. So this is our first option which is in the same. So our answer is your answer number 1 or first option. Question number 9. In a plane electromagnetic wave, the electric field oscillates sinusoidally at a frequency of 2 into 10 power 10 Hz and amplitude 48 volt per meter. The amplitude of the oscillating magnetic field is, the first option here 0.16 microtesla, second option 16 microtesla, third option your 1.6 microtesla, and the fourth option 160 microtesla. See, in electromagnetic wave, electric field is written as C into B naught in terms of the magnitude. So B naught is equal to your E naught by C. It is given electric field here oscillating. So electric field magnitude is given 48 and C is 3 into 10 to the power 8. So this becomes your 16 into 10 to the power minus 8 Tesla, or we can say 0.16 micro Tesla. This is the answer. So magnetic field value is 0.16 microtesla. So first option is the correct option. So question number 10. Infrared radiations is detected by, so we are having 4 options. Option number 1 is spectrometer, option number 2 pyrometer, option number 3 nanometer, and the option number 4 is photometer. See, as we know, infrared radiations are the heat radiations, and that heat radiations are detected by always with the instrument known as pyrometer. So answer is your option number 2 is the correct answer. Question number 11. Which of the following are not electromagnetic waves? The first option your cosmic rays, second option gamma rays, third option beta rays, fourth option your X rays. In these four options, except one, all are the three are the radiations. Just like a cosmic rays, gamma rays, X rays are all are the radiations, while beta rays are these are nothing. It is the radiations or it is the rays produced by the matter particle, and these matter particle is nothing the electrons and positron. So beta rays are not the electromagnetic wave. These are the rays or can be said as a matter wave. So correct option your option number 3. So beta rays is not an electromagnetic wave. The question number 12. Which of the following radiations has the least wavelength? The first is gamma rays, second is beta rays, third is alpha rays, and the fourth is X rays. The least wavelength, the wavelength we can say associated with the energy of radiations. The radiations which are having minimum energy, those having the maximum wavelength, and the radiations which are having maximum energy, those radiation will have minimum wavelength. So out of all the radiations, our gamma rays are the most energetic radiations. So their wavelength will be minimum. So our correct option will be the option number 1. So gamma radiations are the most energetic but least wavelength radiations. Question number 13. The Earth radiates in the infrared region of the spectrum. The spectrum is correctly given by the first option Rayleigh-Jean's law, second option Planck's law of radiation, third is Stephen's law of radiation, the fourth is Wien's law. So this is a direct question based on your memory. So the radiations emitted by the Earth is correctly given by Rayleigh-Jean's law. So our option number 1 is the correct option. So answer 1 is the correct answer. Question number 14. Photon of frequency nu has a momentum associated with it. If c is the velocity of light, the momentum is given as the first option nu by c, second option h nu into c, third option h nu by c square, and the fourth option h nu by c. As we know, energy of photon is written as mc square. Its momentum is given as P is equal to E by C, because E by C is nothing, it is the m into c, and this further also written as h into nu. Now we can write here E as h into nu by c. So momentum of photon is given as h nu by c. So our correct option, your option number 4 is the correct option. Question number 15. If a source of power 4 kilowatt produces 10 to the power 20 photons per second, the radiation belongs to a part of spectrum called the first option your X-rays, the second option ultraviolet rays, the third option microwaves, and the fourth option gamma rays. So this categorization is based on the energy of radiation or the frequency of radiation. See, the first we will find the frequency of radiations. So as power is equal to your, let n is the number of radiations emitted per second, and each radiation have energy, or each photon have energy h into nu. So we will find the value of nu. From that we can get the which type of radiation is this, and the power is given here 4 kilowatt, so 4 into 10 to power 3, and number of radiations are emitted per second, photon emitted per second, that is 10 to power 20, and h into nu. So nu is equal to here 4 into 10 to the power 3 by 10 to the power 20 into h, 6.6 into 10 power minus 34. So from here we can get, it is your approximately 1 by 1.6 into 10 to the power around 17, or frequency is your in the range of 10 to the power 16 hertz, and this is the range of frequency of X-rays. So this frequency of radiation is near to the X-ray radiation frequency. So our correct option, your option number 1 is the correct option. The question number 16. An electromagnetic wave in vacuum has the electric and magnetic field E and B, which are always perpendicular to each other. The direction of polarization is given by x, and the direction of wave propagation is given by k cap. Then first option, x vector is parallel to B and k vector is your parallel to B cross E. Second option, x vector is parallel to E vector and k vector is parallel to E and B. Third option, x vector is parallel to B and k vector is parallel to E cross B. And the fourth option, your x vector is parallel to E vector and k vector is parallel to B cross E vector. As we know, in the electromagnetic wave, velocity vector is velocity is always perpendicular to electric and magnetic field vector. So here wave propagation is defined with a vector k. The vector k must be parallel to the vector E cross B. This is the one conclusion here. The vector k must be parallel to vector E cross B, and vector x here defined as a polarization. So we are polarizing always your electric field vector. So x vector must be your parallel to your electric field vector. So our second option, which have x parallel to E and k parallel to E cross B, is the correct option. So answer number 2 or option 2 is the correct answer. The question number 17 is like this. In an electromagnetic wave, the amplitude of electric field is 1 volt per meter and the frequency of wave is 5 into 10 to the power 14 hertz. The wave is propagating along z-axis. The average energy density of electric field in joule per meter cube will be. The first option 1.1 into 10 to power minus 11. Second option 1.2 into 10 to power minus 12. Third option 3.3 into 10 to power minus 13. And the fourth option 4.4 into 10 to the power minus 14. See, as we know, energy density and energy per unit volume is written as 1 by 2 epsilon naught E square plus 1 by 2 mu naught into B square. And electric and magnetic field vectors are this sinusoidal vector. So E is the written as in the RMS form, the E naught into E RMS square plus the E value that can be said as E RMS by 2, 1 by 2 mu naught into B RMS square. Since E RMS and me, this can be equated, so this is nothing epsilon naught E RMS square. Now this is the energy density. So here the electric field vector, amplitude of electric field given here 1 volt. The epsilon naught value can be written as 8.85 into 10 power minus 12, and E RMS value. E RMS is that is value of the electric field given 1 volt. So 1 by root 2 square. So this is your 4.425 into 10 power minus 12 joule per meter cube. This is the energy density. So our correct option here, around option number 4 is the correct answer. Question number 18. Question is given as a point source of electromagnetic radiation has an average power output of 800 watt. The maximum value of electric field at a distance 4 meter from the source is first option 64.7 volt per meter, second option 57.8 volt per meter, third option 56.72 volt per meter, and the fourth option 54.77 volt per meter. So as per the question here, the point source is given here written like this P, and it has power 800 watt, and this point source is emitting radiations in all direction. This is emitting radiation in all direction. So at distance r, intensity can be given as power by 4 pi r square, and as intensity is your energy density into C, and energy density is written as 1 by 4 epsilon naught C. Energy density is written as 1 by 2 epsilon naught E RMS square into C. So we want E RMS value. The E RMS is equal to your 2I by epsilon naught into C root over. Now this further written as 2 intensity power by 4 pi r square epsilon naught into C. Substitute the value, we can get the E RMS. 2 power is given 800, and 1 by 4 pi epsilon naught your 9 into 10 power 9, and then r square into C. The distance is given here 4, so r square will be 16. C is 3 into 10 to the power 8. Now simplify this. So E RMS we are getting from here. So 16, 8, this is 10 power 8 and 8 cancel. This is your 9, 3 into 3. So this will be your 16 into 8 into 2, 16. So this is your 3000, so that is coming here 3000. 3000 means that we can say around root 30 into 10 root 30. Now ERMS is equal to your E maximum by root 2. So E maximum is equal to your root 2 times ERMS. The root 2 value your root 2 and ERMS your 10 root 30. And root 2 around 1.4, this is your 14 into root 30. And root 30 is approximately 5. So our answer is here could be around, so E maximum could be around, after solving, for 54.77 volt per meter. So our option is your option number 4 is the correct answer. Question number 19. A plane electromagnetic wave of wave intensity of 6 watt per meter square strikes a small mirror area 40 centimeter square held perpendicular to the approaching wave. The momentum transferred by the wave to the mirror each second will be. The first option is 6.4 into 10 power minus 7 kg meter per second square. The second option is 4.8 into 10 power minus 8 kg meter per second square. And third option is 3.2 into 10 power minus 9 kg per meter second square. And the fourth option 1.6 to 10 power minus 10 kg meter per second square. Now see the method how to solve. So this is the mirror and radiations are falling like this. So momentum transfer. So if it is given, the momentum transfer is your, as we know, momentum of photon your h by lambda. So number of photons falling. So if n number of photons falling, the nh by lambda, n is the number of photons, that is also given as power of radiations by energy of each photon hc by lambda. So this is the number of photon falling per second by h by lambda. So now h by lambda you cancel. The p by c. This is the momentum transfer. So p is the momentum, p is the power here. So power of that is given as, and power is given as here 6 watt. Here power is given as can be written as intensity into area by c. So momentum transfer, momentum is equal to intensity into area by c. Intensity given 6, area of the plate is given 40 centimeter square, so 40 into 10 power minus 4, and c is the speed of light, 3 into 10 power 8. So this become here 3 by 2, then 80 into 10 power minus 12. This is the momentum transfer. And if we are further simplifying this one, so this become your 8 into 10 power minus 11. And now this is the for if condition. If collision is, or you can say or surfaces. If surfaces if surface is perfectly absorbing and if surface is perfectly reflecting, then momentum transfer will be your 2 into 8 into 10 power minus 11, and which is equal to your 1.6 into 10 power minus 10. So our correct option will be the option number 4 is the correct option. Question number 20. In the figure here gives the electric field of an electromagnetic wave at a certain point and a certain instant. The wave is transporting energy in the negative z direction. What is the direction of magnetic field of the wave at that point? So as per the first option is given towards positive x direction, second option given towards negative x direction, third option given towards positive z direction, and the fourth option given towards negative z direction. As in the question it is given the energy is propagating towards the negative z direction. See, as per the question here, velocity is along the and relation between the electric field and velocity is given by this expression, and the electric field here along the positive y direction it is given, and energy is propagating along minus z direction, means that indicate your minus k. Now we want what could be direction of B so that we can get the value of J. This minus minus become your plus, so K cross I. If I cap if I am writing here, then that give us your J cap. It means that indicate direction of magnetic field is your positive x direction. So direction of magnetic field will be direction of magnetic field will be positive x axis. So our correct option, your option number first is the correct answer. So this is the question number 20.